Let's compute an example where we get the solution to a linear system from the reduced echelon form of the associated augmented matrix. So here we're assuming that we want to solve a linear system, so we write down the associated augmented matrix and then we do the Gaussian elimination until we get it to reduced echelon form. And so suppose we have this. Now I like to put squares around my pivots to make everything nice and clear. And remember, the vertical line reminds me that I have an equal sign there in the corresponding linear system. And so notice the rightmost column of the augmented matrix is not a pivot column, and so the existence and uniqueness theorem tells us the system is consistent. It also tells us that we know what the solutions are going to look like in terms of free and basic variables. So the pivot columns are columns 1 and 2, which tells us that x1 and x2 are basic variables. Column 3 is not a pivot column, so it tells us that x3 is going to be free. And so the solution, x3 is free, x2 can be expressed as 4 minus x3, and x1 is 1 plus 5 times x3. There's another way to write this, which is if you want to really remind yourself that the free variable is just a free parameter, you can let x3 be t and just say that t is some element in R. x2 is then 4 minus t, and x1 is 1 plus 5t. Either of these are acceptable solutions. The one on the left is the one that's used in the textbook. There's also another way that we can describe solutions, and we'll get to this more when we talk about vectors. But when we get to that point, we can express the solution x1, x2, x3 as a vector. Let's call it x with a little decoration there. And so then this solution vector is x is 1, 4, 0 plus t times 5, negative 1, 1.